So we've been talking a lot about particles, little pieces of things, and probably have mentioned the term atom, but what exactly is an atom? Well, an atom is the smallest particle of an element that still has the same properties of that element. So exactly just how small are these particles that we call atoms? Well, let's take a look. This video will show you, starting with human scale, how small these actually are. So starting at a human, it's about 1 meter. We'll shrink down inside, so size of an egg, a square inch, a coffee bean, an ant. We can get smaller. Now we're at the millimeter, so about 1,000 times smaller than the scale of the human. Here we start to see skin cells as we get smaller and smaller, 10 to the negative 6th meters, which is a micrometer. This is 1/1,000,000th of a meter, and at this size we have the size of some large viruses, DNA, the cell phospholipid layers, carbon nanotubes, alpha helix, and now we're at 1/1000,000th of a meter, 10 to the 9th, and we're starting to get the size of atoms and molecules. Here's a cesium atom. That's a very large atom, bigger than even a water molecule or a carbon atom. And then finally you get to an angstrom, which is about 10 to the negative 10th meters. That's going to be the size of the smallest atoms. But if we keep going smaller to a billionth of a meter, or even a trillionth of a meter, now we start to get to the size of the individual particles inside of the nucleus. So right here, a proton is actually what's in the middle of a hydrogen atom, and we're at about 10 to the negative 15th meters, which is a trillion. So if you took a meter stick and divide that into a trillion parts, the size of a proton, or the size of a helium nucleus, would be 1/trillionth of that size. So you might have noticed in that simulation that there were two things I pointed out. There was the size of the atom, and then there was size of the particles that were actually in the atom. And atoms are made up of 3 different parts. There are the protons, neutrons, and the electrons. The protons and neutrons are both located in the center of the atom, otherwise known as the nucleus. So the nucleus contains both protons and neutrons, while the electrons move around the outside of the nucleus. To give you a better idea of the size of the atom in terms of how big the nucleus is compared to the total size of the atom, let's look at a football field. Now, if we say that the entire atom is the size of this football field, the nucleus, where all the protons and neutrons are, so we're going to put the nucleus right in the middle here, how big would that be? Well, it would be the size of an ant, so even smaller than I can make this picture of an ant, on the middle of the football field. So the atom is really, really big compared to the nucleus where the protons and neutrons are. The other interesting thing here, though, is most of the mass, 99.9% of the mass of an atom, is at the nucleus. Very little mass is where the electrons are. So most of the mass of an atom is at the center, but the electrons and the full size of the atom is really, really big. And you may be wondering, well, what's inside here? What would be inside here on the atom? And the answer is nothing. It is empty space. Most of matter, what we think of as matter, is actually empty space between the nucleus and the electrons. So now let's look at these individual particles that make up the atom. So as you can see, we have the protons and the neutrons and the electrons, but what do these particles actually do? So if I add one proton to the nucleus of my atom, you can see that now I have the element hydrogen. If I add a second proton to my nucleus, so now I have two protons, now I have the element helium, or He. And if I add a third proton, so now I have three protons in my nucleus, I have the element lithium. So what does this actually tell us? Well, it tells us that the number of protons determines the type of atom that we have. So the number of protons determine the type of atom. So all hydrogen atoms have one proton. All helium atoms have two protons. All lithium atoms have three protons. All carbon atoms have 6 protons. Now let's look at one other property of the proton. If we focus now on the image right here where it says net charge, notice that if we have one proton, we also have a +1 charge. And if we have two protons, we have a +2 charge. This tells us that protons have a positive charge. So protons not only determine the type of element that we have, or type of atom, but they also have a positive charge. Now let's look at the neutron. So right now I have a lithium atom that does not have any neutrons. You can see it has 3 positive charges in the nucleus, and let's watch what happens when I add a neutron. When I add the neutron, so right now this lithium nucleus has 1 neutron in it, notice that it's still lithium. That tells us that the neutron does not determine the identity of our atom. Also notice that our charge has not changed. It was +3 over here because we had 3 protons. Over here it is still +3 because we have 3 protons, and this neutron has no charge. So neutrons do not affect the identity of an atom, and they have no charge. Another way to say this is they are neutral. The third part of the atom that we have to talk about is the electron. So let's go back to our original lithium nucleus with 3 protons in the middle and no electrons around it. Remember that the electrons, when we add electrons to this atom, they're going to go on the outside of the nucleus. There are no electrons in the nucleus itself. When I add an electron here on the outside of the atom, notice how the identity of the atom again does not change, but we did gain a negative charge. This negative charge tells us that electrons must have negative charges on them. We also can see that the negative charge balances or matches up with the positive charge. And the charge went down. So we went from a +3 charge when we had no electrons to a +2 charge when this negative charge and this positive charge cancel each other out. If I add 2 more electrons to my atom, notice how now each proton, each positive charge, is canceled with a negative charge, and now we have a neutral atom, or 0 charge. And if I add one final electron here, notice now I have more negative charges than I do positive charges, and my atom gains a -1 charge, and now has an overall -1 charge. We have one more electron than we have protons. So to review the properties of an electron. Electrons are negatively charged and do not affect the identity of the atom.